Lovely. Okay, so I'm Genevieve Tompkins, and as was just said there, I'm the project officer for the rare invertebrates in the Cairngorms project. And I'm going to talk to you about the Pine Hoverfly today, which is this adorable thing that you can see in this photograph here. So Pine Hoverfly, for those of you who aren't familiar with it, this is a species here. It's called Blairophalax. And the larvae, can you see my arrow actually? Because I use arrow a lot. Can you see that waving about?
Yes, we can.
Sweet. Okay, so this is the larvae here, and then this is an adult up here. So it's very much a typical adult hoverfly. It's got this combination of a black body with an orange abdomen and a yellow face. It's critically endangered according to the IUCN GB Red List. It's on the Scottish Biodiversity List. It's a priority species for RSPB and also a sensitive species Scotland for NatureScot. So it's a species that is in quite a bit of trouble and really does need our help. So this is the distribution of the species. I don't know if the bar at the top of my screen you can see, but there's a star as well. So basically there's an old record from 1873 down near Braemar, and then there's an early 1900s records up near Forres as well. But since those two records, really the distribution in the UK has been entirely based around Strathspey. So this sort of area here that's circled is essentially where the species is in the UK. So you can see it's extremely reliant upon the Cairngorms National Park and quite vulnerable. The fly requires Caledonian pine forest, and it's because it needs these big old, what we call granny pines, so big old mature trees, multi-limbed trees, and it's where you see the crack in this tree here. So it's where you've got rot that's set in. That's often helped along by something called Dyer's polypore, which is a fungus, and either it snaps off branches or sometimes it even snaps the whole trunk in half. And you end up with water coming into that, rainwater coming in, and little bits of a mulch sort of bits of Scots pine, and that creates this bacterial soup. And this is what the eggs are laid into. So over here you can see there's these absolutely tiny little white blobs. These are pine hoverfly eggs, and they're laid into this sort of mulch of water and Scots pine fragments. The larvae develop in this environment as well. So these are quite early stage larvae you've got here, and you can see they've got that classic shape. It's called a rat tail maggot shape, which is a rubbish name for it because it makes them sound horrible, and they're actually lovely. But anyway, it's essentially this sort of blob shaped body, quite elongate, with what we call a tail, but is actually a breathing tube sticking out the end. And you can see here these tubes are of different lengths, so they're telescopic. So sometimes they'll stretch them out really far to reach the air at the top. So anyway, the larvae hang out in there as well, and it's also where we find the pupae. So the pupae are not within the water itself, but in cracks and moss surrounding that gap, or if it's cracked off, surrounding the stump. Sometimes the sort of watery bacterial soup element is actually down beneath the root plate, so sometimes the larvae have to get out of that in order to pupate. But essentially these granny pine trees are really essential to the egg, larvae and pupal stage. And then the adult stage, so the adults are flower feeders, feed on nectar, and within the context of a Caledonian pine forest, this is essentially rowan flowers, because these flowers are around at the right time of year. So we're talking around late May to mid-June, although I have to stress that that's based on really limited data really, but that is the time of year we're seeing the adults, and rowan flowers are in flower in Caledonian pine forest at that time of year. So you can see a sweet little adult here washing its face after munching on some of these flowers. So the problem for these habitats are manifold really, but the big problems are the loss of these Caledonian pine forests with these granny pine trees, and also a loss of the understory, so a loss of those flowering plants, particularly rowan. And this is for many reasons, but the main reasons for this really are a move away from these complex forests to plantations. So you can see here, and these are combinations of plantations of still native trees, so Scots pine trees, but also other trees like larch. So you've got some larch down the bottom there, things like Sitka spruce, all of those things. So you're moving away from having these complex forest systems with big mature trees and then new trees coming through to very standardized trees usually not reaching a great age and then clear felling. And then the other problem is often grazing as well, or very much grazing actually. And not only does this prevent the regeneration of Scots pine trees, but essentially it really does prevent the regeneration of that broadleaf understory. So rowan and aspen as well, but in this context rowan's the important thing, is hugely palatable to red deer and roe, and so you just don't get regeneration of those trees where you've got high deer numbers, and as many people will know, deer numbers have shot up over the last few decades really, or century really, within the Highlands. So those are really the problems that the pine hoverfly faces. What can we do about that? Well, the long-term solutions are to try and recreate or get the forest systems back to being these complex ecosystems with lots of different age groups of trees and with lots of different species within them. So the ways we can get back to these nice complex trees with broken and rotting areas is multiple things really, but some of the things that are happening at the moment is ring barking. So that's what this is. So it's where you remove the living layer of the tree around the outside, and that creates standing deadwood, and that just thins out these very tight young forests. So you can see in this area of ring barking that's happened at RSPB Abernethy, there are Scots pine trees amongst that will have been left, and these are generally these nicer bigger trees that are slightly more complex already, and it just gives those trees more space in order to mature and become multi-limbed trees. It also opens up light and space for the understory to develop as well, because you can see here it's very limited in terms of a broadleaf understory. Or the other thing that happens is winching is used as well to create the same effect essentially. The benefit of this is obviously creating deadwood, because deadwood is something that's really been lost from our forest systems, and doing this brings that back in. And there's loads of other invertebrate species which need that deadwood. There's lots of longhorn beetles that need it, things like the pinewood mason bee, which is another rare species, needs it for the nesting. So there's lots of species which will benefit from this as well, because of the recreation of these complex forest systems. The other long-term solutions is more aimed at regenerating rowan. So that's things like putting in these exclosures. So this is another example from RSPB Abernethy here, where an exclosure has been put in around where you've got rowan saplings that are developing, because you do find a lot of young rowan in some of these forests, but it never reaches a height above this level of bracken or heather. It just gets nipped off by grazers once it gets above that. So these will keep the deer out and allow those trees to develop so they become old enough to start producing flowers. And in the same sort of vein really, deer control is really important for allowing the regeneration of these trees. So you can see this is an area here where there's been culling, and you've got these rowan trees that are starting to break through that heather layer. And obviously it will also allow the regeneration of Scots pine as well, so the forest can start spreading out and away from these sort of tight plantation units. So they're the kind of long-term solutions, but we also need some short to medium-term solutions as well. And that is essentially recreating larvae, egg and pupal habitat, where you've also got these rowan trees that flower. So you can see a rowan tree here that's in fruit, indicating it had flowers earlier in the year. And the way that we do this is by taking stumps and then chainsawing or drilling holes into the stump and filling that with this sawdust material. And it's got to be Scots pines in the UK. So far as the data suggests that the pine hoverfly only uses Scots pine in the UK. So you fill that with bits of sawdust, the rain enters that, and then that recreates that sort of bacterial soup that I mentioned earlier. There's a lid on this one. So we put a lid on them as well, but we don't totally cover it over, because otherwise the flies wouldn't be able to go in and out, and also the rain wouldn't be able to go in. But that just prevents them becoming feeding stations for birds, and also prevents the water from evaporating in the warmer months. So this was a method that was developed by the Malloc Society, and originally it was developed for another nationally scarce hoverfly, but it does seem to work quite nicely for pine hoverfly as well. We're now developing that technique further. We're creating what we call troughs. So this is essentially the exact same technique, but we're putting it into the lengths of wood that are left when we cut the trees down to create stumps or to open up the forests. It's exactly the same thing. We just cut longer rectangular holes into it and do the same thing, and we put a little lid on it as well. So it's the same thing. And the other thing we're also experimenting with now is cutting holes into live trees. So these are downward, it's got to be downward sloping to retain the rainwater, but downward sloping holes, again, we put bits of wood chip and such into that, and the rain fills it up and it recreates that bacterial soup habitat. The reason we're starting to experiment is it's possible that firstly, you can get many more stumps or bacterial soup holes into a woodland if you utilize these lengths of wood that are left behind as well. And the live tree holes, we're hoping that they may have more longevity because the tree's still alive, so rot will be hopefully slower, and also there'll be sugars from the tree also entering that water as well. So this is how we're trying to help this species in the short time, by recreating these bacterial soup holes that the species can breed within. We've created these throughout Strathspey Bay through the RIC project, and landowners have been brilliant in getting on board with this. And also we created some last year with the help of staff over at Mar Lodge, because this is where that initial record of, well, near to where that initial record of a pine hoverfly was. But even with this effort, and we've probably got currently about 300 of these are currently in good condition at the moment. So there are quite a few of these in the landscape, but even then, the population of pine hoverfly is extremely vulnerable and the numbers are quite low. So it was decided a few years ago that it got to a stage where we needed a conservation breeding programme. And this took various iterations and has been developed through time, but now it's done with the Royal Zoological Society of Scotland, and originally that was at Edinburgh, but now it's moved up to the Highland Wildlife Park, and it's become extremely successful. So this is the setup that they've got. So they've got these flight cages here, and this is the pots with the larvae within them. So this recreates that bacterial soup, and you can see that the full life stages are being completed. So you've got a mating pair down here within one of the flight cages, and here at the bottom you've got a female that's actually ovipositing, so she's laying an egg there into this over here. So this is one of the oviposition pots, so it's literally just a pot with rainwater and Scots pine chip in it. And there down the other side you can see lots of pine hoverflies feeding on rowan. You can see behind the rowan we've got a bit of bird cherry there as well. So we are experimenting using this setup with the kind of plants the pine hoverfly tends to go for, and it does go for other things like umbellifers and bird cherry and so on, but it seems to really like rowan. And really the species we tried it on, the one that's most predominant in a Caledonian pine forest is rowan. So rowan's clearly very important. So this year the RZS had a fantastic breeding year, just incredible, these larvae. So recently in mid-October, this is what we did. We released just under 3,000 pine hoverfly larvae into specially selected sites at RSPB Abernethy and also at FLS Glenmore. The sites have been selected because they have habitat which already has flowering rowan there for the adults, which is obviously really important. And it also has good regeneration and some fairly mature Scots pine trees, which given a little bit more time will start becoming the kind of trees that will develop these rot holes naturally. So you can see some larvae on this piece of wood, and we literally just pop them out into these troughs and stumps on these sites, and we'll be putting some more out in spring and monitoring that next year. So that brings me to the point of this really, which is how do we monitor them? What is the best way of achieving that? And that's how do we monitor the wild population that's still there, and also how do we monitor these new populations from the releases? Well, we have four options for this really. There's the egg stage, the larval stage, the pupal stage, and the adult stage. The egg stage is more or less out for the count because those eggs are absolutely tiny and would be essentially impossible to find in a wild environment. Those eggs that photograph was taken in the rearing facility. The pupae, again, are not an option. They're not very frequently found and would be just very unreflective of what was happening. They're also not in a pupal stage for very long, so you'd have a very limited period of time to go and find them. Let's look at the adult stage as an option. So, so the adults are quite distinctive, which is good. And the best way to find them is how this volunteer is doing it here, which is essentially staring at rowan flowers until you spot them. And you can tell them apart as well between males and females, which is really important. So the one at the top here is a female, and she's got just a very small amount of orange at the tip of her abdomen, as opposed to the male, which has a much more orange abdomen. So you can tell the males from them apart, which is helpful. There's another way of doing this if you get very close to them, which is that the males, and this is in common with lots of hoverflies, the eyes are touching on the top of the head, whereas the females, there's a bit of head space in between the eyes there. The only problem with this as a solution is that we haven't seen a pine hoverfly in the wild for more than 8 years now. So this is with surveys annually, like this one here that happened this year, at the single known site left for the species in the wild prior to these releases we did in the autumn. So we've been surveying the flower heads of the rowan right next to stumps that we knew had larvae in them, and continually have larvae in them, and yet we don't find the adults. Now, is it because they're simply extremely rare? The population's not very big, and so your chances of seeing one are quite low just because of that. That's probably part of the conundrum. Part of it's also shown by this picture here of this male. Pine hoverfly, if you see it close up and you see certain photographs of it, it looks quite showy. There's lots of orange on the abdomen, face is bright yellow, but actually, if you do see one, they're much more subtle than you'd think. So this sort of reflects that, in that you can see it's not that big. Well, you've not got much context, but take my word for it, they're not that big for hoverflies. And the orange is hidden by the wings often. I mean, it depends on the angle of the fly, but often it is hidden quite nicely by the wings. And again, the yellow of the face, you might get a flash of it, but you don't always see that. And so in the end, you're actually just looking for quite a small black fly. And I think this is a problem, partly because it just makes them much less obvious in amongst all the other flies that you're seeing, but also because I think often, because people very rarely see these flies unless they visited the breeding facility, haven't got the right search image in their head, so it makes it even harder to spot. And it could be behavioural as well. It could be that these flies hang out at the tops of the trees and it makes them much harder to see. We just don't really know enough about it, but essentially the adults aren't a great option because we just don't seem to find them. So that's eggs, pupae, and adults out. So we're left with larvae. So what's a good species to use? Well, they have to be identifiable to species. And are they? Yes, they are, which is a massive help. So you'll see in this slide here, there's an arrow pointing to what I call the face. Well, it is the head end, really. There's two kind of horn-like structures, which are actually for breathing. And then you've also got this arc of hooks, which looks like a little mustache and makes it a very sweet looking thing. And then you've also got the breathing tube. Now, the breathing tube on a pine hoverfly is almost always basically pure creamy white coloured. The species that hang out with the pine hoverfly that you could confuse it with potentially is this, which is Calycera rufa. This is a nationally scarce species that the breeding programme was originally designed for. But you can see in this photograph, it's actually quite a different looking beast. It's, it's got these hooks on the face, which are like eyebrows, and it's also got a very, very short, stumpy breathing tube. So it's a very different looking beast, actually, which makes things easier. Xylota, so that's a genus of hoverfly, and we do find those larvae in these stumps as well, quite frequently. They actually do look quite a lot like pine hoverfly. They have got something of the kind of horn mustache combo going on the face. But I find that the hooks on the face are more coarse, really, and the whole larva is much smaller usually. And also on the pine hoverfly, the tail is, or the breathing tube tail, it is really just cream coloured with a very small brown tip at the end. Well, you can see here, Xylota usually have much more brown at the tip. It goes quite far down the tail. So they're usually okay to tell apart. And then Myothropa florea. So this is a very common species. It's got a common name, which is a Batman hoverfly, and you find this with the pine hoverfly in those Scots pine stumps that we create. You also find it in natural tree holes in things like beech and birch. I found it. So this species again does look quite similar, but you usually almost always have a black line running through the breathing tube, which is quite obvious. And also the face, although it does have hooks on it, like the pine hoverfly, you can see there's a real neat arc to the pine hoverfly's hooks. Whereas Myothropa florea, it tends to have hooks all over its face, much more like a beard, I suppose. So yes, so you can tell it apart as a species, which is obviously quite fundamental. Is there a feasible methodology? Well, if we were talking about looking at the natural rot holes, so holes that have developed within these broken bits of tree, then we'd be struggling because you can't really get to that in most cases. Occasionally you can, but in most cases you would not be able to get to that without smashing the tree to pieces, which obviously would be a bad idea. But luckily, where we are putting in these artificial, I guess, or created rot holes, you can access it really, really easily. And the other nice thing you can do is put these little tags on it, so you've got a good idea of each year the trends for each stump. So it's easy to access, and there's quite a straightforward methodology as well, which essentially is taking your stump, popping the material within the hole into a white tray, sorting through this material, as I'm doing here. Every time you find a hoverfly larva, you take a look at it down the hand lens just to double check which species you've got, and then you pop it into a separate pot to avoid double counting. So it's a very clear, straightforward methodology, and it's also one which can be people can be trained in. So we've got brilliant volunteers, this is some of them here, who go out annually and use this methodology to monitor our stumps. It's a very straightforward methodology, and the equipment is cheap, so that's really important. So you need a white tray, you need an eye lens, and that's practically it. So yes, there's a feasible methodology. The important thing with this methodology, and I think this is true for all invertebrate recording, and it's something that's been really improved upon in recent years, is providing people with good images that they could compare to what they're finding. So obviously you need to train people, but beyond that, having these images for people to refer back to is really, really important. So we've got images of the adults of the sort of the 3 species and then Xylota group as well, and the larvae and close-ups. And then National Museum of Scotland has provided us with some even better close-ups. I think Ashley Wicken's here now, so thank you very much for those. That's really helpful. And what I was talking about earlier, you can see here, so there's the Blaira neat moustache of hooks, and then there's the Myothropa, much more extensive area of hooks on the face. So that's what you see through the hand lens, although slightly less well. And then also pupae. So having decent resources is really important. I have put this resource on our RIC hub. So it's a website for volunteers who get involved with RIC, which has lots of resources with the different species we work with, including this one. There's a link to that at the top of this slide, although I don't know if you can see it because it depends if the Zoom bar is in your way or not. But anyway. Does it give us the information we desire? Well, what we want is first and foremost a population estimate per site, and it does give us that. So the advantage of using larvae are many-fold really, but I mean, firstly, you can pop them to one side, like I said, using that methodology, and this means that you get a good count per stump of the number of larvae you are finding, which is really helpful. With adults, it's very difficult to know how many you're finding on a site, because if you see one on a tree, that's great, and then you go and look at a tree next to it and see another one. Well, is it the same one or is it a different one? You just don't know unless it's got a distinctive break in the wing, like there's some breakages in this one's wing, or if you do a mark recapture, but that is much more time intensive and potentially detrimental to the individual and all sorts of things there. So yes, it gives us a good population estimate, not only for the whole site as a whole, but per stump. So you can start breaking it down and saying, well, which of these stumps year on year are look to be most successful, or at least most used by females laying and by larvae getting to this stage. So you can start really looking at population dynamics as well within the sites. So that's that. Full life cycle completed. Yes, so this is something Jonathan Willett sort of referred to as well with his work. But if we take the releases we did, so we released this autumn, they'll overwinter as larvae and they'll become pupae in the spring. Those pupae will hatch out and become adults in the summer, and those adults will, the females will lay eggs in the summer, and then the larvae will develop through late summer to early autumn until you get back to this life stage here, which is a reasonably well developed larva, which you tend to get end of September or through middle to end of September and October. So then you know that those that you released have managed to go around that life cycle and got back around to a well developed larva, and that's successfully ticking off all these life stages. If you just looked at adults, then all you'd really know was there was an adult in a particular place, but it could have flown there from somewhere else. It could have been blown there from somewhere else. You just don't know that it's successfully breeding in that place. So larvae are brilliant for looking at the full life cycle being completed on a site. Is there any additional ecological information we can get from looking at larvae? Well, if we take this to be, these are the stumps where we released larvae in autumn this year. The green are the stumps where we find larvae autumn next year. You can start looking at different aspects of that setup. So, for example, you can start measuring the distance from the furthest and the closest release stump to where you're then finding larvae next year. And that's starting to give us information on how far the pine hoverfly adults can fly, which is something we really, really don't know at this stage, and is massively important in terms of how close together we start setting up metapopulations, how far stumps can be from other stumps and from flowering rowan in order to be used, and all sorts of questions like that. So that's really important extra information. The other thing we can do is start looking at the stumps that are not used next year. So again, we've got our core stumps where we release this year. We've got our green stumps, which is where we find larvae next year. So adults from this lot have managed to come out and then go to these stumps and lay eggs, and the eggs have hatched and the larvae have developed to a reasonable size. Whereas in these stumps, you'd say that the females either didn't lay in those stumps, or the eggs didn't hatch, or the larvae died off. And then you can start comparing attributes for those different stumps. So is it competition? Is it that the stumps that haven't got any pine hoverfly larvae in have got lots of others, whereas the ones that are used by pine hoverfly have got no other larvae in them? Is it rot hole design? So were all the used ones the standing stumps, and all the not used ones the live tree holes, or something like that? Water temperature aspect, rowan availability, do they not use stumps that are in an area where there's no rowan directly next to the stump? All sorts of questions like that can start being looked at when you're using larvae. And why is that really? Well, I think that there's some core reasons for this. The first is that when you're looking at these stumps, you're looking at a fixed point. So you can start comparing these fixed points with more accuracy compared to adults, because when you're looking at adults, like I said earlier, you find an adult in a location, you don't know that it could just be there, but then when you leave, it'll turn around and go off, or it could have been blown there, or it could be there, but it's not suitable there, all these things. Whereas when you've got these fixed locations where larvae have managed to get to a decent size, that gives you a lot more scope to start comparing attributes of that location. We can also vary those attributes of those particular stumps in specific ways and comparable ways. So for example, stump design. And also when you're looking at larvae, there's two other things. You find so many more larvae than you do adults for pine hoverfly, that you just have many, many more data points. But also the pine hoverfly spends really the majority of its life as a larva, which means you've got more time in order to go around and actually collect this data. You're not waiting to try and hit an ephemeral peak flight window, which you would be doing with the adults. And the last thing I really wanted to say is that I think pine hoverfly larvae are adorable. They're just so cute. And everyone's always very excited about the adult stages of creatures, how stunning adult butterflies are, how stunning adult longhorn beetles are, how stunning adult flies are. But look at this thing, it's amazing. They're pretty tough, given that they just look quite blobby. It's got this sort of what looks like a face, but isn't really, going on here. When you see them moving about, this, what I call tongue, flaps in and out of the face. It's just amazing to watch these things. So I'm just going to put a little word out there to say that larvae are as interesting and as beautiful and as worth spending time on and looking at as the adults. And finally, I just wanted to say about rare invertebrates in the Cairngorms and the work on the pine hoverfly. This is a massive partnership in action. So not only is it the partners of the rare invertebrates in the Cairngorms, which is RSPB Scotland, Cairngorms National Park Authority, BugLife Scotland, Nature Scot, and Butterfly Conservation Scotland. It's also all of the funders of the project, but also the landowners, which are actively putting in these stumps. So that's places like Glenmore, Abernethy, Rothiemurchus, National Trust for Scotland, all of those places. It's the local contractor, Auburn Tom, who is the leader in best practice for creating these now. And he has just taken to this brilliantly and is super enthusiastic and spreading the word locally. It's all of the RIC volunteers who do this monitoring for us each year. It's the additional staff at places like FLS and Abernethy and all these other sites who do all the extra things with us. It's RZS who are currently running the breeding program and doing an amazing job with that, but also help with all the release work as well. And also it's private landowners. So we've got sites with pine hoverfly on them, which the stumps have been actively created by private landowners who have just heard about the project and wanted to do something. So it's just a really fantastic partnership. And that is me done. So any questions, and I'm happy to answer those.